Hello everyone, today we are diving into the world of structured query language, SQL or SQL. SQL is at the heart of managing and manipulating data in relational databases. SQL is the standard language used to interact with relational database management systems, or you can say RDBMS, which we use it to store data in structured tables. Whether you are building a website, analyzing business data, or developing a mobile application, SQL is the key to access and manage the data efficiently. In this lecture, we will explore what SQL is, history of SQL, what are the core functions, and what are the different types of SQL. In the next lecture, we will learn how to install and work with it. By the end, you will have a solid foundation to begin working with databases. Let's get started with a look at the broader data science landscape where SQL plays a critical role. So first, why do we need to learn SQL? SQL is here. In this slide, you can see data science landscape, and SQL is located here as a programming language. So data science is all about extracting insights from data. And databases are the backbone of storing and organizing that data. SQL sits at the core of this ecosystem, enabling us to query and manipulate data stored in relational databases. Whether it's for business intelligence, machine learning, or application development, SQL is a critical skill. It's used alongside with tools like Python, Java, R, Spark, Scala, C and C++, and also data visualization platform to transform raw data into actionable insights. Think of SQL as the bridge between raw data and the applications or analyses that rely on it. Let's zoom in on what SQL is and why it is so important. So, what exactly is SQL? A structured query language, or SQL, is considered as the standard language for interacting with relational database management systems, or you can say RDBMS. An RDBMS organizes data into tables where each table contains rows and columns, much like a spreadsheet in Excel. What makes it relational is that tables are connected through common values. We call them as keys, like primary keys, foreign keys. These keys allows us to combine data across tables. For example, a customer table might link to an order table through a customer ID. The same is for student ID in student and course tables in a university database. SQL lets us create these tables, insert data, update records, and also retrieve exactly what we need with precision. It's like a universal language for databases, supported by systems like Oracle, MySQL, and Microsoft SQL Server. Let's explore the specific functions SQL provides to make this happen. SQL is incredibly versatile, and it is divided into several key functions that allows us to manage and manipulate data. So SQL has four main functions: data definition language or DDL, data manipulation language or DML, data control language or DCL, transaction control language or TCL. First, DDL is all about defining the structure of databases. So with DDL commands, we can create databases, we can create tables, indexes, views, we can define access right to those objects as well. We can create any table for storing customer information or student information, defining columns like name, email, ID, student name, department name, total credits, and so on. DDL also lets us to define access right. It means who can access what. The second one is DML, data manipulation language. This focus on working with data itself. DML commands allows us to insert data, insert new records, update existing ones, delete data we no longer need them, and also retrieve data with queries. For instance, we could use insert to add a new customer or add a new student. We can go for select command to find all customers from a specific city or all students in a specific department. These two, DDL and DML, are foundation of how we build and interact with databases. Let's continue with more SQL functions. Continuing with SQL functions, we now have data control language, DCL, and TCL, transaction control language. DCL is about security and access control. With DCL commands like grant and revoke, we can give user permission to access certain tables or take those permissions away. For example, we might grant the sales team access to view customer data, but revoke their ability to delete it. By this way, we can ensure data integrity. On the other hand, TCL manages transactions, which are sequence of operations treated as a single unit. Commands like commit, rollback, or save point are used in this category. So commit saves changes permanently, rollbacks undoes them if something goes wrong, and save point lets us set checkpoints with a transaction. Imagine updating a bank account balance. TCL ensures that either the entire transfer completes successfully or none of it does. By this way, we can prevent errors like lost funds. Together, DDL, DML, DCL, and TCL give us complete control over databases structure, data, security, and reliability. Next, let's look at how SQL is applied in real-world scenarios. Now that we understood SQL's function, let's explore its application. SQL is used to interact with data in relational databases in countless ways. It allows to access and describe data, define its structure, and manipulate with precision. For example, we can use SQL to retrieve sales figures or update inventory levels. SQL also can be embedded with other programming languages like Python and Java using libraries and modules, making it incredibly flexible. SQL can be used to create or drop databases and tables. We can build views for simplified data access, and also we can define stored procedures or functions for reusable logic. Plus, SQL lets us set permissions to secure our data, ensuring only authorized users can access sensitive information. From small applications to enterprise systems, SQL is everywhere. Let's see some specific examples of where SQL can be used. SQL provides a wide range of programs that need to store, manipulate, and retrieve data. Think about the websites you visit daily, e-commerce platforms, social media, or booking systems. It is also critical for computer and mobile applications. For instance, a fitness application might use SQL to store your workout history, or a banking application might use it to track transactions. SQL is supported by many database systems like Microsoft Access, Oracle, Sybase, Informix, etc. No matter the platform, web, desktop, or mobile, SQL is the glue that connects applications to their data. Let's move on to how SQL fits into the broader database environment. As we can see here, if you go to a web application, behind this button that you write something here and you want to search, there is some SQL command. In here, when you enter your information here, email, maybe it checks for duplication or format. There is SQL. In here, password check is by SQL. This remember me is by SQL. Behind this button, there is SQL. Behind this sign up is SQL. Everywhere, wherever you see some functionality on a desktop application, mobile application, or web application, SQL is there. The ability of SQL to work across different database systems and integrate with various programming languages make it a cornerstone of modern software development. Let's now dive into the SQL environment to understand how databases are structured. To work effectively with SQL, it's important to understand the environment in which it operates. At the top level, we have catalog. It's a collection of schema that describe the database. What is a schema? A schema is like a namespace. It contains the structure of objects created by a user, such as tables, views, and constraints. For example, a schema might hold a customer table and orders table, keeping them organized. Within this environment, we use SQL functions that we have already discussed. Then we have DDL. These DDL commands define the database by creating or altering tables and setting constraints, like ensuring a customer ID is unique. Then we have DML. DML commands let us query and update data, such as finding all orders from last month. Then we have DCL. These DCL commands manage access, like granting permission to a specific user. This structured environment ensures that data is organized, secure, and accessible. Let's see how these concepts come together in the database development process. This slide illustrates how DDL, DML, DCL fit into the database development process. Let's break it down step by step. With DDL, we define database structure during the design phase. We create tables, indexes, views, establish foreign keys, primary keys. We can drop or truncate tables if needed. For example, we might create a table for products with columns like ID, name, price, etc. So this DDL is connected with physical design and also for maintenance that we want to maintain our database. Next, DML comes into play during implementation. We load the database with data using insert with update and query with select. This is where database comes to life as we populate it and start manipulating the data. Finally, we have DCL ensures control during maintenance. We use grants to give user access. We can add to include new permissions, or we can revoke to remove them. Using these commands, we can keep the database secure. This process, physical design, implementation, and maintenance, relies on these SQL functions to build and manage a robust database. Now, let's talk about the SQL standard that makes this possible across different systems. One of the SQL greatest strengths is standardization. The SQL standard maintained by ANSI and ISO, they define the syntax and semantics for data definition and manipulation. This means you can write SQL code that works across different database systems like MySQL, PostgreSQL, or SQL Server with minimal changes. The standard specifies data structure like tables and basic operations like joins and aggregations. This standard ensures portability so database definitions and applications can move between systems. The standard has two levels, level 1 and level 2. Level 1 is for basic features and level 2 is for more advanced features. It is also designed to evolve, supporting new features like referential integrity, transaction management, and user-defined functions. This standardization is what makes SQL so universal and reliable. Let's explore the advantage of this standardized approach. Why does standardization matter? First, it reduces training costs. Because SQL follows a consistent syntax, once you learn it, you can work with any compliant database system. This boosts productivity as developers can focus on solving problems rather than learning new language. Standardization also enables application portability. You can take an SQL-based application from one database system to another with minimal rework. It ensures application longevity as your code remains relevant even as technology evolves. Plus, It reduces dependence on single vendor, giving you flexibility to choose the best database for your needs. Finally, it supports cross-system communication, allowing different systems to share data seamlessly. These benefits make SQL a smart choice for any data-driven projects. SQL has a rich history that shaped modern databases. It all started in 1970 when Edgar F. Cote developed relational database concepts, proposing that data could be stored in tables with relationships defined by keys. This was revolutionary. In 1974, IBM's System R project developed SQL, which later became SQL at their San Jose research lab. In 1979, Oracle became the first to market a relational database with a sparking widespread adoption. Other systems followed like SQL DS in 1981, Ingress also in 1981, and IDM, DGSL, and Sybase in 1986. The first ANSI SQL standard came in 1986, establishing a universal framework. Major updates follow in 1989, 1992, 2003, 2006, and 2008, each adding features like stored procedures, triggers, and support for new data types. Today, SQL is supported by virtually every major database vendor, making it a cornerstone of data management. Here is a summary of 12 major SQL dialects. So the first one is MySQL SQL. This is a widely used dialect in the open source MySQL database, and it is known for its simplicity and speed in web application with features like limit for pagination. Then we have MariaDB SQL. This MariaDB is a MySQL fork offering similar syntax but with added features like common table expression and better performance optimization. Then we have PostgreSQL. This is an extended with PLPG SQL. This is for procedural programming and it supports advanced features like JSON, arrays, and full text search. Then we have SQLite SQL. This is a lightweight SQL and it is a serverless database designed for embedded systems with limited features like restricted alter table support. Then we have Microsoft SQL Server. This is used by Microsoft SQL Server and it extends SQL with procedural capabilities like loops and error handling. This is ideal for enterprise Windows environment. Then we have Oracle SQL. This Oracle PL/SQL combined SQL with procedural constructs like package and triggers, and it is optimized for large-scale enterprise application. Then we have IBM SQL, Snowflake SQL, Google BigQuery SQL, Amazon, Sybase, and Firebird. These are different dialects of SQL. This was a presentation about SQL. We have covered definition of SQL, functions of SQL, application, history, and types of SQL. SQL is a gateway to countless opportunities in data management and analysis. So keep practicing. My goal is to make complex topics like SQL accessible and practical for you. If you have any questions, please feel free to leave a comment below this video. Thank you for joining me today, and I hope you are excited to start exploring SQL in your own project. Thank you and see you in the next lecture.